Hey everyone, and welcome to this explainer. Today we're going to unpack a truly fascinating breakdown by creator Julia McCoy that details a groundbreaking new study out of University College London. This research actually used quantum computing to, quite literally, predict chaos. We're also going to neutrally examine some of the deep theological parallels that McCoy draws from this massive scientific leap.
Okay, let's just dive right into the incredibly bold premise that kicks this whole thing off. Researchers have literally taught artificial intelligence to see order inside what we previously thought was pure, unadulterated chaos. By combining classical AI with the raw, mind-bending processing power of quantum computing, they've basically made the unpredictable predictable.
Here is our roadmap for unpacking all of this. We'll start with the chaos problem, look at the quantum solution, explore how this reshapes our world, examine the scriptural connection, and finally find the order beneath the randomness. All right, section 1, the chaos problem, and exactly why classical computers fail over time. So, you know how classical AI and supercomputers can find patterns in dynamic systems for a little bit, but then they eventually succumb to something called model drift? Over long horizons, they just completely lose the thread. This is exactly why your 14-day weather forecast is, well, basically just an educated guess, and why our economic models totally fall apart during a crisis. Classical computers simply do not have the architecture to hold chaos in mind long enough.
And this is absolutely crucial to understand, because almost every single problem that actually impacts humanity is fundamentally a chaos problem. Weather, atmospheric turbulence, how a disease spreads through a population, it's all chaos. I mean, the human body alone has 37 trillion cells talking to each other every single second. Yet we still can't model a single human cell with full accuracy because classical prediction just hits a brick wall. Which brings us to section 2, the quantum solution. Enter the qubit. The core architectural difference here is just staggering. A classical computer bit is binary, right? It's either a 0 or a 1, and it does one thing at a time. But a quantum bit, or qubit, it can be a 0, a 1, or both simultaneously. Because of this, a very small number of qubits can hold an enormous number of possible states at once, and that's not metaphorically, that is mathematically. And it gets weirder. In this quantum state, every qubit instantly influences every other qubit in the system at the exact same moment. It's a property so deeply strange that even Albert Einstein struggled to accept it. He famously called it spooky. He didn't like it, he couldn't explain it, but it is entirely real, it's measurable, and we are literally building machines around it right now. So how did the UCL researchers actually use this? Well, it comes down to a really specific methodology. Step 1, they used these qubits to find what they call invariant statistical properties inside chaotic systems. Basically, these are hidden patterns that stay absolutely stable even when the surface looks completely random. Step 2, they took those stable, quantum-discovered patterns and fed them right into a regular classical AI model as training data. The result? Step 3 gives us an AI that actually predicts chaotic systems without drifting. The metrics of this breakthrough are honestly stunning. The resulting AI used a fraction of the memory. It held its accuracy dramatically longer than any classical model, and it predicted chaotic systems with around 20% more precision. That is a real game changer. Lead researcher Professor Peter Coveney really emphasizes the magnitude of this. The old trade-off used to be pretty brutal. A full physical simulation of a chaotic system takes weeks, which makes it way too slow for real-world use. On the flip side, classical AI is fast, but it gets things wrong. But according to Coveney, quantum-informed AI for the very first time is both fast and accurate. Moving on to section 3, reshaping our world, going from 6 minutes to 6 months. The scale of disruption we're talking about here is massive. Just look at climate science. We could see hurricanes mapped days before they even form, which would save countless lives. In medicine, simulating exactly how a disease evolves or how a new drug interacts inside the body could mean delivering cures in years instead of decades. Energy grids could self-adjust in real time to shifting demands or storms. And in finance, supply chain shocks and market crashes could be seen 6 months out instead of 6 minutes. This is the moment the curve bends for any field that was previously blocked by the limits of classical prediction. All right, section 4, the scriptural connection. 2 languages describing the same reality. Here's where McCoy's breakdown takes a really fascinating pivot. She argues heavily that quantum physics and ancient faith aren't actually at odds. In fact, she suggests that these two paradigms are simply two different languages describing the exact same underlying reality, the idea that there is a tangible, invisible structure holding the visible world together. She uses this comparison to drive her argument home, linking this quantum discovery of hidden order directly to Colossians 1:17, which is a verse written by the Apostle Paul around 60 AD. Now, while Paul was writing about his faith, McCoy's fundamental claim is that this exact concept, an invisible force holding the visible world in coherent order, is exactly what the UCL team just measured in the lab. Taking this a step further with Psalm 19:1, McCoy's perspective is that ancient scriptures have been saying for 3,000 years that creation is a signal, not just random noise. She argues that quantum computing didn't invent this underlying order. Rather, it's simply giving humanity the eyes to see what texts like the Psalms claimed was already there the whole time. And bringing in Hebrews 11:3, she asserts that scientists aren't just theorizing about this anymore. They are now literally measuring and training AI on the very concept that the visible, physical world was not made out of what was visible. Finally, we reach Section 5, Order Beneath the Randomness, which explores the source's ultimate conclusion on science and faith. So the absolute crucial takeaway McCoy wants to impart is her belief that science isn't competing with faith here. It's catching up to it. She points out that for centuries, we were told that the more we learned about the universe, the smaller God would get. But she argues the exact opposite has happened. The deeper we look, the more ordered and elegantly interconnected reality turns out to be. She does clarify her stance that this quantum order doesn't make the universe itself divine, but in her view, it makes the fingerprints of a designer harder and harder to miss. We'll leave you with this final thought directly inspired by the source material today. If the deepest levels of quantum mechanics truly do reveal stable, absolute order hidden inside pure chaos, what does that mean for how we fundamentally view our reality? As our artificial intelligence and quantum tools grow sharper, and we can finally predict the unpredictable, what will humanity ultimately see when we look at the absolute bottom of the chaos? Thanks so much for joining us for this explainer.